Hello.
Daniel, I can hear you.
All right. Let me just set up my phone then.
Sure, I'll plug in my headset. And we're all set. Can you hear me?
Yep, yes I can.
Yep. Okay. So while you set up your phone, yeah, you help me understand. So it turns out there is an exam on week 3.
Yeah.
The term test that you are concerned is more like maybe the whole topic, something like that. Is it closer to me?
Yeah, it's called CTs, I think. It's
Makes
like mid-years.
Mid-years then, right? Makes sense. So this week 3 exam, it turns out that it is field and thermal.
Yeah, but the field is last year's one too. Wait, no, thermal is last year. The field is
So the last part you asked, the last part was the Stefan Boltzmann constant thingy that you asked me. That's the thermal. That's the last part of the thermal, but you never asked me other things, right? Understand? Then the field. Okay, I'm not getting this. So it feels like your field is supposed to be discussed now, I suppose, right? Starting next week or something like that. Why is it in the exam?
That one I'm not sure.
So
we started a new chapter already.
So you are not discussing fields in any way, right? You're discussing electromagnetic.
Today in class, we went through, wait, let me just pull it out for you. Give me a second. Here we did this.
This is
the new chapter.
I mean, there is a word magnetic field lah. There is.
Yeah,
this magnetic field is going to behave to make it short lah. It is going to behave very differently than what I described to you. Gravity and electric field behaves very similarly compared to magnetic field. So even though they are field lah, they don't work the same way. This week 3, you send me a topic 10 field AHL, describing field week 3. Could you explain to me what AHL means and what does week 3 mean then?
Week 3, sorry.
If you see your WhatsApp lah, that's what you send me.
Yeah. I think he won't be following this like exactly.
Okay.
Roughly.
But the exam will include topic 10.
Yeah, it's topic 3 and topic 10. So it will be 3 I didn't send.
Right.
Topic 10, 2 pictures. Topic 3 is thermophysics. 3.1, 3.2.
Topic 10 is what we discussed in the holiday.
Yeah, so that's good.
So he didn't cover at all topic 10, but he expects you guys as a class to understand. Feel.
Yeah.
I don't get. Now, I'm trying very hard to respect the organization of your class teacher. That's just what I do for my students. So this is not tuition like, okay, tuition has its own schedule, then class has its own schedule. So you just have to make it work, right? I try my best to respect the class organization, but I'm not getting it. Now, let me tell you what happens in the extreme. In the extreme cases that when I think the problem is organization, right? I don't think the problem is mainly you or mainly me or mainly something else. It's mainly organization. Whatever we do, organization is going to be a problem. In those extreme cases, I do tell my student to make their own schedule and to proceed at their own pace. Right?
I mean, he's going through quite well. Like today, he's changed a bit. He went through he went through the slides quite slowly.
He went through what? Sorry?
He went through the slides quite slowly, and he answered all our questions. You can see it.
Right. I see. This is totally different from the notes that I've seen you so far. Good. I like it.
Yeah, because they used to all be blank because he's just everything.
Right. This is the same teacher, but he's going through it better this time.
Yeah, so in like a 1 hour 20 period, we went through 15 slides, which is a lot slower. It used to be 1 hour 20, he done a whole chapter.
Yeah. It's just that makes sense. Okay. So you're telling me there are positives. I like
he's changed for sure. I think someone complained to him.
Good. He changed, right? So there might be a light at the end of the tunnel, but for this exam, it is very weird. Let me confirm one more time. He expects you to do some small exam on fields, which he has not covered at all, and he does not give you practices also.
He started a bit on fields last year, but I'm quite sure he didn't finish it.
So what we discussed, let's just say 90-95% new lah.
Yeah.
Right. And because I'm using my own, questions, we are shooting in the dark with regards to how much or how deep we should understand. Because we went more than what the lecture note is saying. We went more than that. we went to what I think is what you're supposed to be able to understand. That's my thinking, right? Not always, suitable to what he thinks. But all that is total blank last year, and we're going to leave fields behind. That's all. That's what we're doing right now in class.
Yeah.
Oh, right.
I think what he's going to do is he'll assume, like if you look at the picture I sent you,
right,
all the topics.
You're talking about the big one.
The big one, term 1, term 2.
Yeah. Okay. Tell me.
So I think what his process is, like his thought process is that he's already finished chapter 10 last year. So that's why he's just starting on chapter 11 now, and he'll do chapter 7. Basically, he told us that he wants to rush us a bit so he can get to the internal assessment part, which is after topic 7. Because he says he wants us to submit earlier on so we have more time to work on it together. Because it's 20% of our final grade.
Tell me the percentage of the grading one more time. IA, internal assessment, is 20%. That looks like a project work, is it?
Solo.
So
the why I discussed with you about the dominoes.
Understand. That's the 20%. Then what else?
Then the rest is the other 80 is the exam. There are 3 papers, paper 1, paper 2, paper 3.
So 80% is final exam or split between small and big one?
Final exam.
Just one final. Oh,
yeah, IB the IB one.
Yeah, I mean, and there is no. Oh, there is lab work lah. Like paper 1 or paper 2 or paper 3 must be some sort of lab work lah.
I don't think so.
Experiment. Oh my goodness, this is
like paper 1 will be like MCQ, paper 2 will be like open-ended, and paper 3 will be like a special part lah, like a very long one question.
Yeah. That one is similar.
Does the format sound familiar? Because I think
it's just the same as the local, but they have experimental work.
Yeah,
for good or for bad, though. For good or for bad. No, doesn't mean that that's good. No, doesn't mean that. Okay. So again, I'm just clarifying here. Electromagnetic induction in the picture that you sent me is supposed to be week 6. I'm looking at week 6 material at week 0. His reason is that he wants to get to IA very soon. That's his reasoning, correct?
Yeah.
But he's doing some justice to this chapter. He is lah.
Yeah. So that if he goes ahead faster, he does the week 6 stuff now, then he can take his time lah. I think that's his reasoning.
Right.
We'll make sure you understand, because all of this will be new. Atomic nuclear physics, quantum nuclear physics, imaging is all never here before.
Right. Understand.
Yeah.
So let me calibrate myself. Our work to get in advance is not working exactly as we think. We are just somehow slightly more prepared for the exam compared to other students, I'm guessing. That's all. Even that is not a guarantee for your exam to go smoothly, because we are shooting in the dark in regards to how deep we should go, right?
Yeah.
Even then. So that's our situation here.
I realized, right, looking at, if you see my past year,
yes,
like
I'm saying it. Yep, I'm saying
this is all the stuff that we went through in year 5.
Yeah.
There's no mention of a chapter 3, which is thermophysics.
So what was the lecture note that you were asking me of? Like the one with Stefan Boltzmann, albedo, and everything was that?
That one's chapter 8, if I'm not wrong.
And what is chapter 8? I don't see it here also, right? So just take the lecture note. Just take the lecture note. So
chapter 8 is energy production.
Yeah. Do take that lecture note that you asked me and just confirm whether that is thermophysics or is that not thermophysics.
It's nuclear power. Chapter 8. So wind power.
No, yeah.
Sure.
These things are not.
It is, yeah. It is chapter 8.
So this is not the exam.
This falls under energy production, topic 8.
Oh, not exam.
Let me see, topic 8. This topic 8, are we learning it this year? No, right? Okay. That
Doesn't look
is
like it.
strange. Yeah. Let me just take a look at it. He has a physics chat. Visual Symbols 2022, 2023. Yeah, so okay, wait, so can I just share my screen for a sec?
Sure.
All right, can you see it?
Mm-hmm.
So this is a 2022 syllabus. If
Yeah.
you look at term 3,
Yeah.
you're supposed to be taught energy production, electricity, magnetism, and thermophysics.
I don't see you asking me on the electricity and magnetism at all. Thermal
I'm
physics,
quite sure that
definitely not.
topic 5 I learned for sure.
So you like
down
electric
here.
field. That's wow. Okay. Thermal physics, thermal concept and module, I
Kirchhoff's
guess.
laws around that.
I'm familiar with topic 3. I'm familiar with topic 8, but so
For some
exam
reason,
is topic 3.
Oh yeah. Thank you.
Is it? Exam is topic 3, according
Topic
to
3
you.
and topic 10. Yeah, this one say quite clearly.
So lecture note, please, on topic 3. If not, we're shooting in the dark. Then might as well just forfeit this exam.
Okay.
Seriously. There's no point in shooting in the dark. Really, we're just wasting bullet.
Yeah, here you go. For some reason, it seems a bit familiar.
Let's hope so. This is okay. Would you just scroll?
Sorry.
Like, you scroll as fast as you want. You scroll as fast as you want because I can understand. You just make sure that you see. Do you know what this is? Do you understand what this is?
So internal energy of substance.
But in a survey mode, yeah, where we're not trying to understand fully first. Just survey.
Okay.
So this is
definition, specific capacity.
Didn't you learn this in IGCSE? No.
Yeah, I think so actually.
Okay.
Actually, wait.
Okay.
Can I suggest something?
Yes.
I think I have a better idea.
Yes.
Because I recently got an iPad, so
nice.
It allows me to draw directly onto this file.
Oh,
so
I like it.
If I need to get that, then I can put it under the
Yeah.
camera here.
You're talking about Apple Pencil and iPad, right?
Yeah, because it allows me to draw directly onto the PDF and then save it on my device.
Oh, please.
So it gets rid of all the paper and all this messy stuff on my table.
I like. Goodbye to messiness. I like.
Okay,
There's some problem with the iPad, but we'll get through it. All
right. Give me a
you gotta install
then.
Jamboard, okay? You still probably have to install Jamboard. So please do that.
Okay.
That's a good start.
Okay. Just a minute. All right, I'm back.
Right. I'm seeing nice iPad. All right. You may yeah. Let's ignore the keyboard. Let's use the Apple Pencil. Install Jamboard. Access your PDF. All good stuff. Safe to say that you don't need my tablet anymore. Should be.
Let's see if this works first.
Let's see.
Jamboard. All right. Okay. It is It's only somewhere. Ah, there it is. Okay. Let me just go to the shared folders then. See if I can. Let's see if I can download everything.
Mhm.
See shared folder, files. So we're doing thermal physics now, right?
You
So I
don't
download a
share,
copy.
yeah, you don't share. Open a new
Can you
window.
share?
Open a new window. That is not what you want, I guess. This is OneDrive, is it? Sorry. This is
Yeah.
OneDrive, is it? Oh, you
Is it
have to
possible to
open in
save
another
to?
app. You have to open in another app. Then you probably can save over if that's what you mean. So open another
Yeah,
app.
I like
Yeah.
to save directly. Oh, okay.
Right. Then
I'll
you
save
use
to
whatever you
files.
like. If you
Yeah,
save
that's
to
not gonna
files,
happen.
then you're saving a copy of it.
Yeah,
That's what
that's
you
what I
want.
want.
Okay, good.
So
You?
I can make my notes directly onto it.
Good, good, good.
Okay, and then chapter 10, right?
You need to go to your files in this case. This is not files, huh?
Yeah,
This is your OneDrive, right?
yeah.
Yeah, you need to go to you need to exit and go to the file directly. You save
Yeah,
your
I'm doing
files.
the 10, I'm doing chapter 10.
Right.
Let's do both of them. Oh, second.
Right, bye-bye. And then I hope you have your favorite app. Your favorite app is Microsoft Document
Right,
or
yeah,
PDF
I
editing.
was doing work just now.
All right.
Just get rid of that. Files, physics, and now chapter 3. All right, great. Then I can just, where is it?
Okay, you position
Yeah.
slightly nicer for me. That means you adjust your phone to go a little bit. Yeah. Now, if you position your iPad like this, is it nice for you to write or not?
Yeah, that works.
Okay, it's not nice, then I don't want it. It should be nice for you. Good, good. So you scroll at your speed. I'll just be following you.
Okay.
So this is new. Whoa.
Yeah. Actually, right, to even get rid of the phone, why not I download Zoom on here? Then I can share
Screen share.
direct.
Yeah,
Yeah.
you can.
Okay. That's a lot more efficient.
But let's do that after today's lesson, right?
Yes.
We should use.
I agree.
Yeah. So.
Okay. Maybe make this smaller.
Sooner or later we'll still need the phone because we cannot get rid of paper. That's just my.
Okay.
So yeah. So let's stop here for now for today. So you're gonna survey this chapter and then quickly at the end of survey you're gonna tell me what you think.
Just like this.
Yeah, that's not highlighted. That is.
There you go.
Yeah, there you go.
Just get rid of all of this. Okay. So just remember the formula. Is there like a formula for this?
No, that's understanding. I'll explain it. Oh, there is a formula for the kinetic energy later you'll see. Oh, so this is new. Wow.
Definitions. Specific capacity.
We're preparing for an exam, and yet he's teaching something else.
Defined as.
Yeah, I like it.
Energy required to release a unit mass of substance by 1 Q. Thermal capacity. Okay, so they'll probably test the difference between these two, right? Like, is that a possible question? Difference between specific capacity and thermal capacity.
Of course, yeah. That can happen, yeah.
Okay. Specific capacity, Q is MCT. I know this one. It's highlighted anyways. Estimating specific heat capacity of a group. Brilliant. Okay. Thermal energies. This looks like I might need this. IV is power. What's the unit of IV?
The unit of power is
it watts?
Yeah, joule per second or what? Same thing.
Joules per second. Or... Well, that joules looks like. GQ is thermal energy, right? So this will be joules. Cos A times T, that makes sense.
Good.
What is this, the MC?
The M and the C is the same thing as what you get above, the MC delta temperature. The slide, just 2 slides.
So the L is, what's this weird thing over here?
The liquid, M of the liquid, and C of the liquid.
So mass, M is mass, C is specific heat capacity.
Yep. Yeah, that thing. No? This thing is exactly the same. Okay. Yeah, we have been talking about like the same thing for the past four slides, kind of. So maybe the last slide that you're thinking was an application, kind of.
Okay. So specific you changed delta. Wait. What's theta again? Sorry, just slipped my mind.
Theta is the slightly more popular symbol for temperature. So theta and big T, in this case, big T temperature. Why do they use theta? Well, I don't know. It gets confused with angle. But if they use big T, they get confused with period. So pick your poison. It's supposed to be temperature there.
Okay. So energy supply. What's lagging?
Sorry, lagging.
Over here.
I'm lagging. Sorry. No. Show me everything. Oh, that's clearly not lagging. That's. Let me see the picture before this. That's not lagging, right? They're lagging. So I don't think lagging means that. I think lagging simply means insulation. I don't know why they call it lagging. Yeah. The insulation causes the heat to escape and mess up with our measurement. So insulation, right?
Insulation. Thermal energy supply is also, but this is assumed, it's not real world.
We assume, yeah.
Calorimetry,
so this is ideal, so that means it's meant to make our life easier. Of course, in reality, that's not true, and they will ask their question based on that. No, in reality, this. So the last 2 marks, anything like that. But you don't have to worry about that right now.
Yeah, can you say lagged?
So it's not the internet lagging, yeah? It's not the I play a game and it's lagging. Not yet.
Okay, we have a new thing now. Moving particle theory.
And suddenly he switched to this ideal thing. Right? No, this ideal gas thingy.
Yeah, this is like the thing that says like all particles move randomly, right? A constant motion, constant and random motion.
He is describing something like that, but his goal later on will probably be the ideal gas thingy lah, and whatever ideal gas meant for physics law. So let's see lah. Right. This you shouldn't find unfamiliar, right? No.
Yeah. Okay.
Point. This is also should be common for you.
Is there an explanation for this part? There is, right? Why it's like the heat.
Yeah, they will like to ask you to do that. So the energy is used to do something other than raising the temperature. Now, raising a temperature no longer works very well as a phrase in this chapter. Why? Because this chapter talks about the small particles point of view. Let me just say something because I want to know whether you know, right? Okay. From the small particle point of view, that means atoms. Can you imagine this? They don't have temperature one. Temperature for us, we measure temperature. Oh, your temperature is 35 degrees, 36 degrees, 37 degrees. I ask your atom, okay? I ask the atom in your head. I'm just measuring the temperature. He has no concept of temperature at all. The particle is not having any cold or hot temperature. The particle is just vibrating. A 37-degree atom in our hair is vibrating at a certain speed. A 40-degree one is vibrating slightly faster. He doesn't understand temperature if you so
he only understands in terms of like how fast it vibrates. So.
Yes. So how fast it moves in terms of gas. So in gas, you say it moves fast. In solid, you say it vibrates fast. In liquid, you say it vibrates and moves fast. Just a mixture. The point is vibration, moving at a place, and shooting around, moving not on a place, is both kinetic energy. So when you increase the temperature of an atom, you don't make it hotter. That's not his point of view. His point of view is you make it go faster, whether vibrating or really, really flying. So increase of kinetic energy. Therefore, when they ask you to explain this change of state, the molten lead, when the lead is when the lead is still molten, and you make it colder, correct? That's what you're doing right now. You're making the molten lead colder, correct? Yeah? When you're still making the molten lead colder, the first part of the graph, you're lowering its kinetic energy. Make sense? When you lower it further and you hit that line, you ask me for an explanation. The explanation is the heat drawn out. This is not the energy put in, but the energy put out or drawn out. It's not lowering the kinetic energy. It's not. The lowering, the energy drawn out is used to lower the potential energy. Where did that come from? Where you check out the first highlight that you make lah. You say total energy or internal energy is potential energy plus kinetic energy. So the potential energy here is not a concept. No, it is because when you go from liquid to solid, the bond between the atom changes, correct? The bond between the atom does not have anything to overcome the bonds. In this case, to form the bond. Yeah. So if you draw the energy out, it allows the bond to reform. And that bond has nothing to do with kinetic energy. So this is as much as they can tell you. So whatever, man, let's call it potential energy. That's really the extent to how they explain to you. Yeah, the bond is not kinetic energy. So let's call the bond potential energy. That's it.
Wait, so this is like an exam answer. The heat drawn out does not lower the kinetic energy, but instead lowers the potential energy.
In order to form the solid bond. That's the physics answer. Like the chemistry answer will go deeper. But sorry, so you don't take it. Yeah, so you don't. So I shouldn't be. Something like that. This is probably good enough for physics. In chemistry, they will ask for. Right. So you check the slide later. The slide will have this kind of thing. Now, as you go back to the line and go back to solid again, then the heat drawn will now lower the kinetic energy again. Right. Okay. So now, if you are kind of happy with this page, let's move on for now. So that means this is new. What I explained to you, it kind of sounds new.
I mean, I find it before. I just need like a refresher.
Okay. All right. Oh, he is explaining it in a slightly lengthier way.
Long-winded.
And this is going up. Okay, this is heated. This not cooling it down. So you have to reverse the whole thing when you explain cooling down. This is heating.
Increases.
So kindly read the chapters, page, see whether it makes some sense.
Okay. Well, so this is like a very in-depth answer.
This is how deep they want you to go. So it pays to understand this chapter, this page like it does. Slowly.
So you talk about particles vibrating with sufficient thermal energy to break from the fixed positions. Still, that's a solid produce will become IMF. He added the does not go to increase the energy and break. Okay.
All right. So they throw phrases here and there. It will be, if you want to clarify something, go ahead.
So the different phases is the
solid, liquid,
from solid to solid to liquid. From solid to liquid is melting, boiling.
Yeah.
No, melting, freezing, melting, freezing.
Melting. Yeah. Oh, that's what you mean. Sorry. Yeah.
And then between liquid and gas is boiling, condensation.
Yeah.
There's another word for condensation, right? A fancier word. Precipitation.
No, it's not. You cannot use that word.
Okay.
Sublimation is from solid to gas. If I remember, I'll tell you. But you probably know when you see it, right? Okay. So again, focus on this page first. Are you sure that you understand this page kind of?
Yeah.
What I told.
I will try to say from memory. I don't look at the iPad.
Sure. I'm not asking you to memorize anything.
I mean, it's good to know by heart. So as temperature increases, the more heat energy that is absorbed is converted to kinetic energy, right? Instead of potential energy.
Of the molecule or of the particle. At least you should say that.
Yeah, kinetic energy of the particles, which causes them to vibrate at a higher frequency in their positions.
Right, sure thing.
In their fixed positions, that comes from solid to liquid.
So you shouldn't talk about solid to liquid yet, because that's the melting point. You're just talking about the solid being heated.
Okay, so as the particles vibrate, we see the particles gain enough kinetic energy to overcome the the bonds, the intermolecular bonds.
You can say that.
Right.
You can say that.
Is that-
That's not what they say, but you can say that. No, that overcome the intermolecular forces. So they're being
intermolecular force.
vaguer
IMF.
here,
Okay.
right?
Intermolecular forces, allowing them to vibrate until they overcome the forces, making it into a liquid state.
Wow,
okay, I need to revise.
Yeah, no problem. But you're getting there,
Yeah.
You're getting there, no? Right? So that's what they care about, and that breaking of intermolecular forces is what they meant by gaining potential energy.
Is the word phase change a keyword? I need to mention that.
They find it nice if you use it properly, but phase change simply means going from to right, or the other one to that's all it means. Right. So it's a slightly shorter way of saying something, right? And this phase, just to say, is totally not the phase that we talk about in harmonic motion. It's just different, right? This is not that phase. 180-degree phase change. We talk about the thin film, which we are not talking about again right now. Now, when you're happy, go ahead.
Right, vibrational, rotational, and translational kinetic energy. What is this? So this is from liquid to gas at boiling point, the gain sufficient energy to overcome the intermolecular forces. IMF. To mention IMF. This get together state. What does it mean by this? Like a larger translational motion?
Right. So you notice that because we are not talking about from liquid to gas, kind of, right? From liquid to gas, we don't just deal with vibrational. This rotational, you can imagine that vibration is slightly different from rotation. Okay. Vibration is your SHM and rotation is, well, your rotation, right? And translational is basically the molecule actually moving around, right? Not exactly flying around, but moving around. And you appreciate that a liquid will now have vibration, rotation, and translation. So far, so good?
Yeah.
Now, the gaseous molecule. Can you appreciate that a gas molecule will be, well, translational motion will be flying around in a much faster rate than a liquid? Much faster.
Much faster.
So you don't imagine gas as small particles flying around extremely fast, like faster than bullets, something like that. You don't imagine that. I suppose.
Yeah.
People won't imagine that. That's what's happening. Now, my point is, in the liquid state, the translational speed, right, kinetic energy speed law is much smaller than at the gas situation is much faster. Just take my word for it for now, right? Therefore, the vibration and the rotation, which does happen in gas, becomes also not very significant. I mean, they are still vibrating and they're still rotating, but the speed of it when it travels is already much bigger than the other parts. So we are now concerned with translational motion only in gas. Now, I'm already trying to explain your question. Does it make some sense?
Yes.
All right. So you see in gaseous molecules, suddenly vibration and rotation disappear. They don't disappear. They just become a little bit irrelevant.
So it only matters in liquids and solids.
Yeah, or rather in comparison. Or you can say something like the heat is used to increase the translational kinetic energy, something like that. That kind of tells them that you understand what it is being used for. So breaking the bond as per usual, and then increasing the translational kinetic energy. Because for gas, that's what they care. Gas only cares to do that.
Okay.
Physics.
Could you give me like a sentence definition for translational kinetic energy?
There is no need to translate that. No, I just give you the understanding though. It's the speed of the thing flying around. Zipping around.
Okay.
Sorry, is that what you're looking for? They don't ask you for definition usually. They don't.
Yeah, speed of particle.
In terms of it
Kinda.
zipping around, yeah. So different from vibration speed and different from rotational speed. This is the speed that you know. You don't vibrate, you don't rotate, you as a human being just do a translational motion, a moving, right? Something like that. That's what you will understand.
Okay.
Right. Okay. So other than that, the concept here should be about the same. Right.
Yeah.
Okay, right. So yeah, this is just
Process of phase change.
This seems like
sorry.
This seems like a reverse, right, from the previous page.
Yeah. Sorry. Just give me a moment. I remember something. I have to chase my teacher to upload the latest slides.
Okay.
Once he went through chapter 11, but he hasn't uploaded them to his thing yet.
Might as well you go on doing that, remind him, and I'm gonna stop you from reading further. Now I have a comment here. Now, before I comment, again, I'm just asking you, can you, like, if you're doing something and I make a comment, like, is it good for me to do that, or should I wait until you stop in terms of focus?
Yeah, just go give your comment.
Right. You are basically committing to preparing the exam, right? Week 3 exam. That seems like a good idea until, let me just break down the situation here. Until we realize that the teacher is covering another chapter, which is also not exactly very easy. You may think that understanding the lecture is easy, but until you see the question.
I think it's best to just read through at least. Like, just read through these things, just clear up anything that I have. But if you think it's not wise, then what do you think is better to do? You would like to go through the chapter?
I think none is wise. So I'm just trying to describe the situation so that both of us understand. Then we're not surprised, right? So I'm just taking like 3 minutes to do this, right? So the situation
at the moment, okay. Yeah, sorry. I was going to say at the moment he's going through the new chapter quite slowly. First of all, second, he hasn't uploaded it online yet, so I don't really have any. I can't redo it here, so that's not ideal. Then third, I mean, I would like to know what's coming out on the exam or the test. So those 3 points kind of make me more inclined to just getting this done.
I grant that for today. So let me explain what will happen in these 2 weeks, right? I grant that for today. I totally agree, right? So you and your classmates are being put in a situation where I think there is no nice feeling outcome. So if you go through this slide only, you still will not be able to answer some of the questions in exam. Yeah, you may be able to answer one of the basics ones. So that feels a little bit good. Then you see the whole question and you don't feel good because you don't even understand the question. Meaning we do have to invest more time in just at least looking at the question and just discussing it. That's the minimum for you to get something, right? So it's not going to be just today. Make sense? That's just normal for exam. But you cannot just read the lecture note and expect to be able to do the exam. That's normal for physics, correct?
Yes, correct.
That's what your situation is right now. wow, you're facing an exam which they never tell you, so you're reading from lecture note, and I must say that you're reading it quite well. You don't feel sleepy. You're doing all the good stuff, right?
Rather engaged.
You're rather engaged, and I'm surprised because this slide is definitely not engaging, but at least it makes sense to me. I like you, so I'm liking you. I don't like the situation. You have to invest more time to see some, some benefits in exam, at which, therefore, you cannot invest time to understand the chapter that's going on.
Drawbacks.
Right. Yeah, so there are drawbacks. If you do the other way, then, you will lose your exam, doesn't feel very good, but you get the chapter that's going on right now. Right? Which one is better? Which one is worse? I just see it from your final exam point of view. Well, both doesn't feel good. If you go half-half, that's another option. Also won't feel good one. I just tell you that. It won't feel good in exam, and you also won't feel good when you're trying to answer the tutorial question or whatnot. You won't feel good one. So you are being put in a situation where there is no, what do you call it? There's no nice feeling outcome, even though you're very engaged. I am trying to appreciate you by telling this. I'm trying to appreciate you by saying you are doing the right thing, even though there is no right thing.
How is that
It's
possible?
impossible. It's not impossible because you're committing to the subject, regardless of the organization of the class. In defense of your teacher, right? I want you to respect your teacher. In defense of your teacher, maybe he's trying to do something better this year. It entitles some sacrifices at the start because there is no point sacrificing at the end one. If you want to sacrifice something at the start, then you start to, realize your gains as you go on. So that is a good move if he sticks to it, especially the part where he tried to explain slowly. So there will be sacrifices. There will be right? That's all I'm trying to say. That's why you are doing the right thing. Maybe your teacher is doing the right thing. Maybe the class is on the right track, but there will be sacrifices. And it is currently not anybody's fault at all. You're doing your best. That's what I feel. Continue doing your best and go past the disappointment, whatever the disappointment will be. For a while, I'm just talking about the first month. Okay. Right. Now, before we continue, the second practical question is, what is Finding doing right now? Finding has its own schedule.
Yet.
When will you know their schedule, so to speak? Not, I don't mean time. I mean,
no news from them at all this year.
Like we're gonna do this first, and then that, and then blah blah blah. And
no,
then,
nothing. It's been radio silence. I can go chase the teacher. Actually, I should probably do that now.
It will be nice. See, that's another right thing that you can do. And that's what I'm seeing from you. See, and there's some initiative. I like it. I like it. I like it. You're chasing them. Right? That's what you need to do when you're facing a slightly disorganized class. You should be chasing them. Good. Are you doing that right now? So if you're not, then I've said my piece. If you're at peace in discussing this, I follow you. I follow you. No problem. You're doing the right things.
I think it's safe to assume that we will be following the school in terms of chapters. So probably we'll be doing.
How can findings follow the school schedule closely? What's going on here? I'm missing something here. Usually tuition center cannot do that. What's going on here?
As in, it will start in the order. So chapters. Wait, chapter 8 first. Wherever I sent you first, the one that he's essentially skipping. So, topic 10. So he'll do start on fields. This findings will probably start on fields.
So finding is like giving you what the school class is not giving you.
Yes.
That's nice.
I'm just sorry, he's reading my message. I think he'll give me answer now.
Historically, last year, does findings do a lot of good practice question?
Yeah, it's always a lot of worksheets and practice.
So the way they do it, they ask you to do it, they give you things, and then they discuss with you is quite okay for you?
Yeah, it's really quite clean.
So findings is going to make up for your school class lack lah. What was lacking there?
Yeah.
That's not bad. That's not bad. Then the different schedule makes sense because you have to handle 2 or 3 different schedule. I don't know which master we're serving right now, right? But so far sounds good. Okay. Okay. Now
Okay, my hunch was correct.
Yeah, so
his classes begin next week.
Okay.
And they start on topic 10. Topic 10 is the one I just showed you. The
graph field and the
fields. Yeah.
Good. I'm looking forward and when they finally give you questions. Right. Hopefully the sooner the better because you're ready. Okay, you're ready.
Okay.
Now, in terms of lecturing, so that's when they discuss the basic concepts of the new chapter. How does finding do it?
What do you mean?
Some can do it very dryly, just follow the lecture, whether it's abstract or concrete, don't care. But how do they explain it to you or deliver it to you or engage you in the class?
They give like worksheets. So every chapter will have a few worksheets and lecture their own notes. So the notes will be like a summary of formulas and like rules, and then there'll be questions to go through.
Right. Okay, here's my hope, and then we can continue here. Here's my hope.
Okay.
I hope that the way I explain to you and the way finding explained to you feels is going to be complementary. When you experience finding, then you will know whether it's complementary or not. The way they discuss question and the way I discuss question should be similar, not complementary. But the way they explain should be complementary. I hope that's what's happening. So I'm just waiting for your update, your feedback, see whether that's what's happening or not. All right? Okay. What shouldn't happen is the way I explain and the way I explain is clashing. That shouldn't happen. If that happens, just tell me immediately something is going on. Right? Right. So I'm happy. I will follow you with this lecture note again, right?
Where is the battery saver? So I continue reading.
Go ahead.
So this is decrease in temperature. I don't understand. Okay, you can teach.
Okay, this thing. Yep.
This is required for me to change place. You could say like latent heat is like the energy between state changes.
State changes, sorry, you were saying what?
State changes. It's like an energy between changes in state.
From the start of the phase change to the end of the phase change, you're giving input, right? Input lah, energy input, or you're drawing out energy, right? Either way, right? That is called latent heat, correct? Not very fancy understanding. That's what it means, lah.
So change in heat without change in temperature.
No. There's no such thing as change in heat. Just heat you put in or heat you draw out. You always put in heat, right? Whether it is, dropping in temperature or not dropping in temperature, right? You're always putting in heat. The latent heat, just talk about the heat you put in at the start of the phase change. That means the straight line until the end of the phase change. All the way, you are still putting in heat or drawing heat out. I acknowledge that. That is not definition, but that is a very good understanding lah. If you understand it that way, good for you.
What do I use this? Oh.
Yep, you can do that. Yep.
Oh, this is very useful too.
Oh, it is? Okay, good. I like.
Oh, thank you. Yes, we can. Learning new things. Specific latent heat. So when they say they add on the word specific to anything, that it just refers to per unit mass.
Yes.
Right.
That is what they mean, and it will mean like that across other topics. So this is quite standard lah. Good for us to know.
Thank you. Means latent heat is just amount of energy absorbed or released during a change of phase.
The latent heat, yes. If that makes
so down
sense.
Here, over here, yes. I should add on during change of phase.
Yeah. And only during change of phase. Yeah.
Latent heat of fusion and vaporization.
Just a small comment, okay? So fusion is a more proper word compared to freezing. It is, however, to me, it's a very confusing standard word, but that's what they use. Fusion means freezing anyway. Okay? From solid to, I'm sorry. Then comes the definition, which is confusing, right? The latent heat required to change or from solid to liquid. Solid to liquid doesn't sound like freezing, correct or not? That sounds like melting, right? Fusion is not melting. Fusion is the reverse of melting. Well, freezing, whatever. The fusion is freezing. That's because you must understand from solid to liquid. You put in energy, right? The exact same energy you have to draw out when you go from liquid to solid. So the number is the same. It's just that one is putting in and one is drawing out. I hope that makes a lot of sense.
So are you saying the note is wrong?
No, the specific latent heat of fusion without concern of whether I'm putting in or drawing out. That's just for you to understand yourself. So specific latent heat of fusion and for melting is exactly the same. One way 2000, the other way also 2000. They don't tell you which one. Which one is this? Is this putting in or draw out? You think about it yourself lah. The definition doesn't care. I hope this makes some sense. Why would they choose to define that way? Heck, I don't know. I think that's confusing. It's confusing, yeah. Heck, yeah. Oh, their intention is to confuse you. Maybe you have solved the mystery here. Sometimes I wake up and I suspect that. Right? Now, vaporization from liquid to vapor. Wait, that's correct. What? That's vaporization. What? Beats me lah. This point beats me already.
This could also be vapor to liquid.
Yeah. Also same from vapor to liquid, which is called condensation. What's vaporization? The nicer word for boiling. Just say it. Can you say specific latent heat of boiling? No. They want vaporization. So just saying, okay? Just saying.
Can. It means solid to liquid. Yep. Okay. Can. And all the stuff don't need memorize that. Okay.
Right. Basic questions. It would be nice if you can understand. It will be nice.
Okay. What is near to this temperature? Use MC delta T. Okay, yeah, this one I understand.
All right.
It's all MC delta T, yeah. Right.
No, because latent heat has no delta T. If you're talking about the chapter lah, if you're talking about this question, yeah lah, this question, no phase change one.
Yeah,
It's still liquid to liquid, liquid to liquid. So no phase change, so no latent heat, so just delta T. You're all correct.
Is this safe to say?
Let me put it another way. So when there is no phase change, but you mean there's a heat input or output, like that's what you mean, right? So if there is no phase change, then it must be increasing the kinetic energy of the molecule. Must be, right?
Yeah.
So that must mean an increase or decrease in temperature. So not just generally, but must be lah. Must be. That is not the wrong thing to think about.
Okay.
After these three examples, I would like you to cover the answers for the next page. Yeah? So that's where the real test comes from. Right? So make sure you ask anything you want in this question, in this page, because these are still easy. The work example, I will have you close the answer. Lah.
Okay. Just open up a new note then. Alright. There we go. Alright. So just hide the answers. How much energy does a pizza have to move on 1.5 kg of water? And pizza from water to ice, so there is phase change.
Right. Okay, what I want you to do is I want to screenshot that question into your note-taking stuff. So that you know what the question is, like, I don't know, 2 weeks from now when you need it, I suppose.
Okay.
Right? Either way, either that or write immediately in the PDF. Either way, for now, that has enough organization, right? So can you do that quickly? Can you? If not, we'll be using Jamboard. If not, that is weird. That's not working, right? So yeah, that's working. Good. Now paste.
media.
Oh, you have to do that. Oh, this is
Okay,
this hurts. This hurts.
there you
Right.
go.
Okay. There you go. Still better than right. Good. Good. Right. So you can close your. You can. I mean, you can split your screen off for now, lah. Right. Okay. That's okay. That's nice. Yeah. That's good. Now you do this. Right. Now you do this.
Okay. Back to this. So you need to go from what?
Liquid. Yeah. Yeah.
Solid.
Nice. You're thinking the right.
Okay.
Thinking about the right thing.
First, you need to overcome your. You need to overcome your specific latent heat of fusion.
Wrong. That's not the first thing you need to overcome. That's wrong.
Oh, sorry. It's to go down 20 degrees.
Very good. You're right.
So
therefore,
delta T.
MC delta T. Good. Therefore, MC delta T. Good.
Delta T is
right.
1.5 times 4200.
Right. Times. Right. Don't press your calculator. This is enough. Right. So then after this, what?
Can I just do the question?
No. Just continue with the next. I'm trying to make you faster because I think you can. Right. Right.
Okay.
So what's the next
after
step?
this, you get, let's call it X.
Right. Sure.
Okay. So then after that, we need to do the latent heat of fusion of ice.
So how?
0 degrees.
Yeah. How?
So
how do we do that?
It is, you just multiply by the, maybe 3.33 times 10 to the power of 5 times 1.5.
All right, you're going to stop there, and then that's it. Right, going to stop there. Right, good. Then
no,
is there another step?
Not done yet. There's minus 12.
Oh wow! So how do you do that?
Is MC delta T. You go.
And that will be.
Where is it? 1.5 times. Specific heat capacity of water is specific heat capacity of ice, right?
Wrong.
So now
no, they are different. They are different. Heat capacity.
How do you find the specific heat capacity of ice?
You don't. They usually give it to you. This is weird.
But okay.
Yeah,
so
they usually give it
times
whatever C ice, whatever C ice. Cancel. Correct.
Find out
X, Y, Z. Right. Okay. Good. Right.
Let's see.
Right. So let's see whether my claim is correct or not, right? That you don't find the sea of ice they are supposed to give you. Just look at the answer right now. Right. But the thinking process, your thinking process is not that, I suppose. You have your IGCSE behind you. Good.
What chapter is this again?
This is, I don't know you call it.
Chapter 3. Oh, can I spell? Chapter 3. Coursework. Okay.
Right. So check out your PDF or something. Return back to your PDF. Can you split your screen again or something? All right. Okay. Good. Right. Check it out. Where does the 2100 come from? I wonder.
What do you know?
What do you know? They are supposed to give you, and that is the correct number. It's not 4200 divided by 2, okay? It's not. That 2000, actually it's 2000 something is the sea of ice. Just Google it. So that you know it's not 4200 divided by 2 or any nonsense, right? Like, I mean, it's your question is not good. So it's not doing you justice. Specific heat capacity of ice, right? Never mind the cal. You need joules.
There you go.
There you go. Yeah. So it's 2000 something. Yeah. It's not 4200 divided by 2. It's not there. It's not. So they're supposed to give you this. So you have something to ask your teacher if you can ever ask your teacher. Is this question missing something? You need to ask this so that you have no concern at all going to exam. Okay? So what are you supposed to do, right?
Let me just put this under subjects.
Are you organizing yourself or something?
Yeah.
Good, I like.
What do I edit? Yeah, whatever lah. Just spell it wrongly.
Take your time to organize, that is fine. Yeah? Taking your time to organize is good.
How do I give it a interesting? Oh, I can drag it. Okay, so put into physics. Can I make a subdivider? It's a divider. Next, done. Here's one maybe chapter 3. This one is
Right. Don't over organize at the start. You'll be adapting your organization to your need, but it's okay so far. It's okay. Yeah? You might want to add the page of the note also if you want to if that helps. So just say that this is page, I don't know, page 11 or something.
What page is this?
Check it out.
Page 22.
Page 22. Just write down page 22. It will help you later if you ever need to. And please take a note that where is sea of ice? That is something to take out from this question. Sea of ice where? Write something. Right. Okay. So really a good job for this first one. You understand it? Not your fault, right? I don't think it's your fault, right? How about the second question? Let's give it a try. If you could make it into the same note, just a different page, then it will be much better for organization.
Sorry.
Can you open this note and continue with a new page of it? Right.
Yeah.
I think that's better. Nice. Okay. So copy paste the next question. Yada yada.
Oh, okay. Yeah, that works.
Okay. Don't look at the answer, please. Don't look at the answer, please.
I will not dare.
So far we're doing a very similar process. Oh, sorry, I didn't see you. Sorry. So far we're doing a very similar process to the field, right? Just that in the field the lecture is longer, and therefore the question is also harder. Here you're doing a very similar process. So good for you. Anish, I'm sorry I didn't see you for quite some time. How long were you here?
About 5 minutes, not that long.
Right. Okay. So your senior is almost done. So it's just doing questions, right? So Anish, from our WhatsApp, you're saying that you haven't started school. School started when tomorrow, is it?
No, I went to school today.
Oh, right. So give me some updates if there are.
I went to school and I got a lot of homework already. But the math seems fine. I actually already know him from beforehand.
Your new math teacher?
Yeah, I knew him from beforehand.
Tell me what to expect.
He's nice. He can be a little bit slow paced, I think, from what I've seen. But other than that, he's okay.
Do you expect, good explanations?
Yeah, and also he's very organized. Means like he sends all the materials online.
Yeah,
So everything.
I like organization. Right. Sorry, I'm talking to a senior just for a while. See, Daniel, they are supposed to give you specific heat capacity of ice, right? Right. Okay.
I see now.
Right. Okay. So back to you, Anish. So where did you know your teacher beforehand?
Oh, he is the discipline master, but he's nice.
Right. He is fair, he's reasonable, he can teach. That's what you're saying.
Yeah.
Good to hear. Will this be a temporary one?
No.
I hope so. Right. So have you got a taste of his style, or just meeting him or what today?
No, this is the first time I've met him teach.
So he hasn't actually taught you guys.
Yeah.
What's his plan? Have he told you like what's his, he's gonna follow the syllabus, he's gonna do this, he's gonna do that?
Oh, he sent something, which was, hold on.
Right.
Oh yeah, so what he did was he sent what he's gonna do for each like couple weeks.
If you could show me,
I'll screen share if you wish.
Sure. Oh, no screen sharing, sorry. If you could send me for now.
Oh, okay.
Screen sharing later, yeah.
Oh, I can't. I don't think I can share this.
Because it's in your drive or something.
Yeah.
You cannot download or copy or save. No, nothing.
No, I can't.
Screen share is fine.
I seem to be a little bit stuck.
Right. Let me just split the screen for now. Okay, guys, please wait for a while. I have to do something. Let me do this instead. Okay, that's yeah. There. So Ainesh, give me some time, yeah. I'm gonna address your senior. Okay, so you're assuming that the ice will go to 0. That is not the right assumption.
This is how much energy is required to heat it up to 0.
Yeah, your MC delta T is okay to 0. You're assuming that it will go to 0 exactly. That may be true, they may not be true. Judging from the situation, there's more tea than ice, so maybe you should be assuming that the ice will completely melt and even go beyond the 0. My point is you don't know. My point is you wouldn't know. You're supposed to find that out. Right? So
the latent heat of fusion.
The other problem you have is that the delta T of T you assume to be 20. That's definitely gonna mess you up. You should assume that you do not know. So you should say it is 20 minus the final temperature, which you don't know. You're supposed to find that. See, at what temperature will the phase, at what phase will the final mixture be? So you should assume that you don't know, because that's the whole point. Right? One last thing, see whether you can understand this. Then I have to go to your junior for a while and you think. J from T or whatever, the heat from T is going to be extract out. This is heat out from T, correct?
Yeah.
T is going to cool down, heat out from T. The ice is going to be heat into the ice. Does that make sense? The ice is going to melt.
Gain ice
will be equal to gain heat away or heat extracted from T. And that is how you will solve for the final temperature. Does this make sense? However, you should make an initial assumption first so that to make your life easier, you should assume that the T is, the ice is like completely frozen or at the phase change or go beyond the phase change. You should make at least one assumption. That's okay to do. Please make an assumption right now.
I'd say it doesn't go past phase change because it don't give me any of the fusion.
If it does not, then it follows that your T should be assumed to go into the phase change because they have to meet at the same placement. Either way, you have some trouble. You cannot avoid the trouble. You understand me? If you're assuming that the T does not go beyond phase change, that means it goes like maybe to 5 degrees, something like that. Then the ice will be the one crossing everything. Your assumption hits both ways. Understand?
Okay, so my understanding is that you calculate, what I calculated is the J from T.
That's right? the heat taken out.
So like you have like 2 bars, you have the ice, which is like -10.
Yeah.
And then you have your T, which is like 252,000.
Right.
So then this chunk comes up here, it just takes out like a portion. That means what's left to be this lah.
Yeah,
So
it's
I
not
just
252,
do-
by the way, not 252, so it's less than 252 probably, right? The
So
ice,
I do-
the ice will melt, right? First thing first, sorry, the ice
Yeah.
will go to 0, and then it will go through the phase change. So that means there will be a little hit of melting lah.
But
And
if they
then
don't
it
give
will
it to me, do I assume I just don't need to
just
do it?
take
or
from
what?
the first one, because they should always be giving it to you. They should,
Okay.
right? So we are assuming that the ice will further melt, and then the ice will go into water, and water increase in temperature. So the ice will have three sections, just like question number 1. Make sense? Right? Give it a try. Okay. So I'm looking at your screen sharing, Ainesha. So this is what your teacher give you. This is just a standard thing. Someone week 1, he wants to talk about circle.
Oh yeah, we are doing this, and there's homework on this.
You are going to start with this, right? So calculus will be later. Understand? All right.
Yeah, I learned the word tangents because I never knew what this was.
But you should have an idea what tangent is right now, right?
Yeah, now I.
Good. Then this is circle 1 week. Very ambitious, right? Then term 1 week 2 is going to be something different. I thought you covered this last year. No? Can we confirm that?
I think it's a bit more of a revision. And anyways, I'm very weak in polynomials, so yeah.
Understand? So now calculus, okay, just going down. Okay. So can scroll down a bit, scroll down, just down. You see that the technique of differentiation? Go up a bit, just go up a bit. There, you see the chain rule, product rule, and quotient rule. There you go lah.
Yeah.
So according to this plan, he wants to cover the 3 rules in the first 3 weeks, right? Week 3, week 4, week 5. That's what his plan is.
And week 4 is pretty much Chinese New Year.
Right. All this topic seems difficult, seems like a very weird description until you see what they explain. You almost already cover all of this. Yeah. It doesn't mean that you understand, but it means good for you lah. You can do the questions immediately. Can you?
Yeah.
Okay, going down to week 6. Application of differentiation equation of tangent normal. That is what you have covered. We talked about this at the last time. This is the last part. The rest you have not covered. So far, so good. Understand? So you should be cruising and doing the best, not enjoying yourself up to week 6. If you don't do anything else, we will be doing a lot of things. We should be going forward, but you should be okay from week 3 to week 6. That's at least what we should expect. And
yeah,
right. So going down, just curious. So he wants to do that until week 10 and then term 2 already. No? So finally, integration. You have already covered integration a little bit. No?
Yeah.
Right. And then integration week 1, week 2, week 3 until week 6 application. As you can tell, a lot of calculus. Right. Then WA and revision. Right. Okay.
WA
so
is weekly assessment.
Right. Wow. Okay, understand. So 6 weeks for integration, that's quite a lot. Week 2 and then going down. Okay. These things I understand. They just go down quickly. Down quickly. Yeah, geometry and no. Go down quickly. Yeah, go down binomial. Yeah. This is normal. This is normal. Okay, understand. Go down. Just go down. Down. Understand. Okay. Now here's a question for you. Your new teacher probably only have a very rough idea how good or how bad you guys are last year. Right? Does he say anything about last year's topic? Does he say anything?
Too bad last year almost half our class failed overall. So
that is easy for him to find out, right? Does he say anything about what he's going to do?
No, because last year's academic results is very hard to base off on because it's not only our class. Every class failed, like half of them, because the exams were so hard.
I know.
So I don't think he has any idea.
So he doesn't say anything like the fact that he's going to inherit problems from last year. He doesn't say anything for now.
Yeah.
Okay. Is there anything else that he said?
No, not really. He's the one who mentioned that he can be a bit slow paced at times.
That's not bad, I suppose. It's really not. It's really not. Would
Better
you
slow
do you
pace.
have, does you do you have his lecture note, like the one's coming, the circle one?
Let me see.
You check it out. I'm going to come back to you later. So, Daniel, let me just see what you did. Yes, yes. Sorry. Scroll up a bit, just a bit. Just scroll up a little bit for me. Yeah, sure. Right. The latent heat is there, and then you add them up. The adding up is fine, but you didn't count for the fact that the ice will need to increase temperature. That means when he becomes water. So the ice is now water because you say latent heat melted, correct?
Yeah, but you don't know how much it increases to.
The same way that you do not know how far the T will drop. It's the same temperature.
If you don't know how much the T drops, then you leave it as the variable that you need to find.
Wrong.
Delta T.
So use a different color. So I have to go faster because we have 2 more minutes. So red color, please. Change the delta T of the T into 20 minus T final, right? So TF is T final. So do that first.
Okay.
20 minus T final. This makes some sense, right? You start from 20. Right? Now the ice, you need to add one more component. So X, Y, and Z. So the ice, the last component is the MC delta T. So you add another MC delta T, and the delta T will be from T final minus 0.
No.
In the ice. So add another component. You have only 2 components. You must add another component, another MC delta T, because the ice is now water. Add the ice. Yes, over there. So nothing, is it? Nothing for you, Ainesh. No lecture notes. No lecture.
So I added more.
Right. Tell me your update on chemistry in 2 more minutes. So you say ice. You say ice or water. So because the ice is now water, so that is to remind you the ice is now water. Please write it down. Ice or water. Yeah, something like this is the weakness of not using Jamboard. So I have to say to you. Okay, good. Now this is the Q for water, right? You write down the Q for water. Not the T, but the water from the ice, right? So the MC delta T will be the mass of the ice originally, the C of the water, and the delta T is TF minus 0. Does this make sense for you? The 3 components added together will be Q drawn out. Correct? The 3 components added together. That will be equal to the QMC delta T of the T.
Right, so this plus
that.
Okay.
So this plus that is going to be equal to 3 times 4,200 times 20 minus final. The Q out from the T.
3 times
4,200, I think. 4,200 times 20 minus 1. Now look at this. This is one equation and one unknown, isn't it?
Yep.
So you can solve for T final, and that's how you get your answer. Does this make sense? Is this the first time you've seen this kind of question? Think about it, do it, and then look at the answer here. I will have to switch to your junior. You can stay, but I won't be paying attention to it. Okay. Okay. So Ainesh, I need some update on chemistry if there is one.
I don't think you'll get any update until Friday because my first chemistry lesson is on Friday.
Right. Physics?
You will get one tomorrow.
So what's going on today in general, not just math?
today is late arrival, so there was lesser lessons today. And it's mostly just introduction to teachers. So yeah, not much. Only math.
Only lit and math, really. That's all.
No, I had humans. I had history and geography.
All right. No surprises. No other surprises.
Yeah.
Understand. Okay, let's go to your Jamboard. I'm going to show you what this chapter is going to be. And then you can follow your teacher more quickly. However, 1 week is a little bit fast. I was hoping for 1.5. I guess they don't have much time. So we cannot use we use the holiday overview for now. We'll just continue from there. Good, page 11. Yeah? 11. Now you can stop your screenshot for now. All right. Okay. So I'm sorry. Just to make sure, yeah. Could you screenshot this week 1 and just put it in the Jamboard just to make sure that I'm not missing anything.
Okay.
So Daniel, you're supposed to solve for that one equation and one unknown, right? It definitely can be done.
Yep, I'm doing it now. Just give me a while.
Right. If you have screenshotted, tell me.
Oh yeah, I have.
So the Jamboard is not reacting. Why is that? So let me see. Oh, I'm at the wrong page, maybe. Oh yeah, I'm at the wrong page. Okay, I understand. Right. So just a minute, I'm gonna get a keyboard. Sorry. Keyboard in. So yeah, Nishan, still trying to find out.
Yeah.
Finding my drawing pad. Drawing pad. You messed up today. Oh, got it.
Okay, got the answer.
Yep, so you can check the answer key, Daniel. And what I hope is that you understand what's going on. Yeah, I think you get around 60% correct, right? So that is already a very good step. Now, Hainesh, I'm gonna summarize what the chapter is on, basically, right? So can you see whether he's doing it the same thing, and can you accept that we need to do this? It's not just because I say so, and it's not just because the answer key says so. Right, so I'm drawing a circle, Hainesh. I'm claiming this is the center of the circle. The center of the circle is always O. It is not, yeah, they cannot put C. So if they ever use the letter O, it means the center of the circle. One more time. In drawing a circle, the rule that they must not break is that the center must be O, and O must be the center, nothing else. Okay?
Yeah.
Okay. So one more time, if you see O, you don't have to ask, is that the center or not? It must be. They cannot break that rule. Right? They cannot. Just it's just a very important thing. C is not the center, right? Just saying that. So they can use C for something at the perimeter, lah. They can also use C for something not at the perimeter or not at the center. Just saying. Okay, so far so good. Right. So now, what is the chapter all about? Right. Now, Ainesh, would you please put another two random points on the perimeter, please? Right, there's another random point and another one. Good. Now, I can form this, right? I can form this. Obviously, this is a triangle, right? I'm pretending that the bottom guy doesn't exist. So just pretend with me for a while. Can I understand? Just pretend for me. Again, obviously, that's a triangle, but I am pretending that it is not a triangle. It's an open thing, okay?
Okay.
And I'm going to draw another triangle, which is also open, which also, again, well, it is actually a triangle, but I'm pretending that it is. I'm pretending that it is. This guy is x, and therefore, this is always 2x. That is the first claim. Here it is. This is what I mean. Angle at center is twice angle at circumference. This is always true in a circle. If they have time, they'll go to the proof. I doubt they have time. You have to use this immediately. They don't have to prove it. You're going to use this to your advantage. Any question, Ainesh?
With the rule?
Yeah. That this is always true. If there is x, this is going to be 2x.
Okay.
Right? Let me show you something else immediately. Now, you understand what angle at perimeter or circumference is? I mean, like the angle is on the circumference or the perimeter. So I'm just saying that this is not considered angle at circumference, but it is on the circumference. Just say, can you?
Yeah.
Right.
Sorry.
Sorry, Daniel, you're saying?
Am I done already?
Yeah, for today. I'll see you for this week. I think I have to see you tomorrow. Okay?
Tomorrow I'm not free there.
Oh, because you were never free on Thursday, right? Yeah, correct. No, correct.
Yeah.
That is fixed, right? That is fixed, right?
Yep.
So Sunday and Wednesday. Can we fix that?
Oh, Sunday, what time?
Oh, you're right. I haven't sent you the time. Okay, so this is the last week where I will be unsure of my timing. So I'll send you the timing like by Friday, like the latest, something like that. But it will be on Sunday. Then if there's some discussion, we can still discuss. Okay. Right. So if you're going through the route of preparing for exam, you are for the chapter of thermal, you still need to do some more practices. That's the minimum to have some impact on your exam. Can you?
Yeah.
Right. Okay. Then whatever it is that you have prepared, I want to see it whether you prepare for your thermal or you do some field practices again, or you do some practices for the electromagnet one. Anything, but let me see it on Sunday.
Okay, sure.
All right. Okay. All right. And then I'll see you on Sunday then.
Okay. Thank you.
Bye.
Bye.
Okay. So I am giving you another perimeter angle, Ainesh. Here's another perimeter angle. Okay. Make sense, yeah? I'll call this angle Y. Okay. X plus Y is always 180. Here is another guy. This is called the alternate segment theorem. Fancy word for I face you, you face me, we are 180. Simple, right?
Yeah.
Look at this angle. Let's call this angle something else. You name it.
Z.
Z. And this angle?
W.
Z and W plus equal 180. Same thing. Right? I face you, you face me, we are both perimeter, we add together 180. Okay? So far so good. Can you accept that?
Yeah.
Right. This guy is 2y. We are doing this thing again. Can you see that? This is all about seeing it.
Yeah.
So you can accept 3 things or 4 things. This is x, this is 2x, double. This plus this 180. This plus this 180. This one double. You can accept all that.
Yeah.
All right, give me a random number, please.
20.
So let's say that x is 20. Let's say that. Find everything else as much as you can. Using the rule I just mentioned, you just have to use them.
Okay. So 2x is 40.
You have to write down. You have to write down.
Okay, hold on. Let me get the tablet.
Sure thing. I'm sorry, just now I circled the wrong thing. There was an alternate segment. It was angle in opposite segment.
Sorry, do you say something?
Yeah. I circled the wrong thing. I am not supposed to circle alternate segment herein. I'm supposed to add angle in opposite segment. It was this plus this equals to 180. That's angles in opposite segment.
Oh, okay. Okay, while I set this up, get on my tablet. What are we gonna do for Sundays?
Sundays, right? So I'm gonna finalize the schedule by at least latest Friday, right? So this week is the last limbo week we have. So the plan is like this. For Sunday, it is always math. That means the priority, right?
So it's
For
always
Sunday is always math.
math.
I mean, we need a lot for math anyway. So Sunday, 1 hour math. Okay. And then
I think Sunday is 2 hours. 7 to 8 and then 9 to 10.
I think there will be a change. I think there will be a change, right? I think there will be a change, but whatever it is, Sunday will be math. Right? Sunday will be math. So whether 1 hour or 2 hours. So on Monday, that will be the science day. So in your case, Monday will be chemistry. Physics, I'm gonna pretend it doesn't exist for now. We don't have much time. Okay?
Okay.
Sunday is math. Monday is chem, and then whatever other days we will fit in whatever is necessary. So Sunday is almost certainly 1.5 hours. Monday almost certainly 1.5 hours. They will do some justice to both math and chem. And then whatever other days you have it, Tuesday, Wednesday, or Thursday, that will be filling in whatever we need. If that makes sense.
Okay, sure.
Right. Is that what your question was?
Yeah.
Right. So something like that. So just to add some organization to our life. Now, you should know your activity schedule by the end of this week. I hope whether certain days you are free or certain days you are not.
Oh yeah. Fridays as always, and then but then we don't have tuition on Fridays.
Correct. No, Friday and Saturday, so that shouldn't matter. So are you saying on Tuesday, Thursday, and Wednesday, you are currently still open, but you should wait for confirmation, right? Right?
I think on Wednesdays I'll be a little bit more tired than usual. Like today,
right.
To be fair, today this is my first day of school. I haven't woken up so early in a very long time. So maybe it's because of that. So we'll see next from next week onwards, I think I'll be able to study.
Right. Starting next week, I will be having you, more organized, also more on time. Also, today is still a bit of a limbo, lah. So, your exercise plan, your waking up, your on time, your setting up. Starting next week, we make it proper, lah. Okay.
And
You're saying?
Oh, okay. I just was saying that next Tuesday I'm not attending because I have VIA.
Sorry, what was the VIA?
Values and action. So I got to do it.
Right, no problem. So currently we don't know whether Tuesday you'll be having class or not. But Tuesday, Wednesday, or Thursday is we should finalize it by next week, kind of. What is your real needs? I don't see you doing all full 5 days. I really don't. I don't see it unless you can show that you are effective every day. But that almost never happen even in holiday.
True.
Don't waste your father's money. But if you want me to waste your father's money, then I will do it for you. But there's no point to me. I think what you need to do is to be effective on the days that we want to have tuition, something like that, and to simply have a good study habit. Okay.
Yeah.
So I don't think the plan will be let's have tuition every day. Okay. I don't want to. Yeah, I don't want to do that to your dad. Yeah. Okay. Okay. So yeah. So what is going to happen on Tuesday, Wednesday, and Thursday? Let's talk about it. Next Sunday and next Monday. Something like that. Okay.
Okay. Sure.
Right. So again, for today, so you're writing something, I hope. There you go. Right. So I agree with the 40. I don't agree with the 100 because
160.
Oh, 161.
Oh, my hands are a bit off because I haven't written very long.
Right. Wonderful. Right. Wonderful stuff. I like it. Right. So you would notice that 320 plus 40 is 360. You would notice that, yes?
Yes.
Does that make some sense?
Yes.
Good. Now, what is this? What is you call this Z, right? So I'm going to label it Z, right? And this guy is W. How come you have nothing on Z and W?
Z and W, they would be 90 each.
If you're talking about they look like 90, well, I guess so, but you cannot say that at all. You cannot say that, oh, Z is 90 because it looks 90. You cannot. My point is this, in exam, they'll ask you for a reason, right? So why is this 160? You're supposed to say, oh, this is 160 angle in opposite segment. You're supposed to write it down. You're supposed to write down in short form. So the short form is angle, OPP, segment. You're supposed to write this. 160 bracket angle opposite segment. So you're supposed to quote the reason. You don't have to explain why it is true. This is your answer. Understand?
Mm-hmm.
You're supposed to quote 40. What is it, 40 or 40? Angle at center twice angle at circumference. Just a short form. You're supposed to write. That's 40. So you get the mark, something like that. You cannot say that Z is 90. Looks like it. You understand what I'm saying? Cannot. There must be another reason. Okay?
Mm.
So what is Z and what is W?
Z and W are equal, correct?
No, I'm almost certain that they are not.
No.
What's the relationship between Z and W, by the way?
What is the relationship?
Yeah.
Z, Z plus W equals 180.
That is the correct relationship. Visually, you can see it. You may not understand it too much though. I agree. I never explained the reasoning why, but visually correct. They are opposite segment. They are total 180. That is their relationship. So what is Z and what is W? Any idea?
I'm thinking. No.
And you would be correct, Ayush.
Oh,
You
okay.
are correct. We do not know. There is not enough information. The question cannot ask you like that. Correct.
Yeah.
If you know Z, you know W because they have a relationship, correct?
Yeah.
If you have W, you have Z because they have a relationship, but you don't have one of them, so you do not know both. Nothing wrong with that at all. Understand so far?
Yeah.
You say that you're not a visual person, but get rid of that notion. This is one of the most visual topic I've ever seen, right? One of the most visual. If you think that it's about memorizing the formula, that's just a totally wrong way of teaching. And I hope your new teacher is not going to teach you that. Yeah. I hope your new teacher will teach you how to see. Just did that. Okay. Now, a few details first. Any questions about?
No.
Okay. So I'm going to talk about relationship a lot. Your teacher will not use that phrase, but he should mean the same thing. So I talk about relationship to make our discussion in questions very easy. So I'm going to tell you what I mean, relationship. Now, I put forward the line that is supposed to be there, like the triangle. Like I'm just closing the triangle, right? I am going to call this point a random name. So I guess A, B. Just calling this C. It's not a center, and I'm going to call this D. So far, so good, Ken, yeah?
Yeah.
Right. Now, AB is a very important, there's a very important word for it. It's called a chord, right? So I'm going to use this thing, a chord. So AB is a chord. Let me explain what chord means. A chord simply means a line that cuts through a circle. So it is not tangent. Let me draw you a tangent, right? Here's a tangent, right? That is a tangent, correct? Visually. AB is not a tangent, AB is a chord. Simple, right?
Yeah.
In that same way, AC is a chord law, CB is a chord law, whatever. There's a lot of chord here, isn't it? Right?
Yeah.
I just randomly choose AB to start our discussion. Now, this angle faces the chord AB. Make sense?
Yeah.
This angle also.
Okay. Yeah.
This angle also. In a stranger way, this last angle also faces the chord, although we don't usually see it that way. I mean, if you see it this way, it faces nothing, no? But maybe we can say the chord face this angle. The point is, 20 face this chord, 40 face this chord, 160 face this chord, and 320 kind of face that chord also. So far, so good?
Yeah.
That's why they are in a relationship. 20, 160, 40, and 320 is in a relationship. What does that mean? It means when you know one, you know everybody. That's what it means. Because they are in a relationship. You understand me? Let's try this. Give me another random angle.
40.
Right, so I'm going to put, I don't know, I'm going to put 40 here. I'm going to spice it up by putting 42 degrees.
Okay.
Now, I'm saying to you visually, 42 face this angle, face this chord, this face this chord, this face this chord, and this face this chord. I'm claiming that 42 is in relationship with all other three. So you can find everything. Let's give it a try. What is X? What is Y?
42. So 2x would be 84. Y would be 180 minus 42. So
but whatever that
130.
is. Yeah, whatever that is. And then this guy will be twice of that.
Yeah,
right?
So 276.
Correct. So you know all that because you've gone through that already. Now I'm gonna make it slightly more clearer. Gonna give me a rather big angle, please.
What second quadrant?
Third also can.
Okay, 196.
Okay, 196 I should put here. 196. I claim that because this faces the same chord, they are in a relationship. If they're in a relationship, you know one, you know how many?
4.
You know all.
Oh.
There'll be more than 4. There'll be more than 4, but in this case, it's just 4. So I claim if I give you 196, you can find everybody else. Let's give it a try.
So Y would be 3.
Come on. Use your calculator. Tell me an angle.
I was trying to just get my mind working. Y would be 98, and then
Right. Good.
X would be 82.
Good. Then.
And the 2X would be 164.
Good. And if add this 2 up, it's going to be 360. Just check first.
Yeah.
Good. So,
yeah.
Yeah.
It doesn't.
So the claim states, right? Once angles are in a relationship, you only know one, you can find everything. Okay. Now that means X and W are not in a relationship with this form. That means because knowing them doesn't help in any way in finding Z and W, at least not yet. Understand? There's no direct line. Now, why is that so? Because Z is facing a different chord. Visually, Ainesh, Z is facing what chord?
B is facing
Z, yeah, this thing is facing who? Sorry.
It's facing W.
No, the chord. No, I mean there's an angle here, but I want you to see the chord, not the angle they are facing.
It's facing this chord.
Which chord would that be? Good. The chord is CD.
Yeah.
Keeping it simple, because Z is CAD. Oh, CD is the chord. W is CBD. So what chord is W facing?
W is facing
CBD.
the same chord.
The same chord. So they are in a relationship. So no one knows.
Yeah.
But CD is not the same chord as AB. Why? Because AB is the chord that all 4 are facing, not the same chord as CD. So they are not in a relationship. So you don't know one, know all. So far, so good.
Yeah.
This no one, know all will give you a lot of confidence in exam. That's why I give it a lot of emphasis. Now, I'm gonna give you one more thing that you're supposed to know, basic stuff, and then we can try questions. Yeah. Right, so there is one more thing. I'm going to draw another perimeter angle by giving another random point. So let's call this random point E. And then I'm going to connect it here. And then I'm going to connect it there. Let's agree first. Is E a perimeter angle, correct or not?
Yeah.
You should be able to see it visually. There's no definition here, right? So let me just draw that nicely. Do you see that this angle, let's call this angle, I don't know, you call it?
A.
Small a, then, yeah? Small a, not big.
Yeah.
Is small a related in a relationship somehow with X, 2Y, 2X, Y, or with Z and W, or no relationship?
I think no relationship.
There is, and it's a one you have to see visually. Look at small a.
No.
What is the relationship with who the relationship is?
2Y.
2Y I agree. It is in the relationship with 2y, which means in the relationship with 2x, y, and x also, because they're all in the same family. Right? Correct or not?
Yeah.
Why? Because what is the chord that A is facing?
The AB chord.
So the same as everybody else here, correct?
Yeah.
So in this case, let me just say A is going to be equal to X. This is the last thing, no? This is angle in the same segment. There you go. If this is 20, this is 20. If this is 40, this is 40. If this is 31.5, 31.5. Okay? The relationship is defined by chord. I'm not sure whether your teacher will say this, but this is true. This is true. And this is how I usually see it in exam. Makes things much faster. Any questions so far?
No.
So look at the syllabus. You still don't know what this is. This is actually easy. I'll show you later. You know what is the chords of a circle. You know that?
Yeah.
You don't know what's radius perpendicular to tangent. I mean, I think you know what's radius. I think you know what's tangent. But what is this radius perpendicular to tangent? You'll see that later. What is tangent from external point? Any idea?
No.
Right. Now, all the fancy word here, these three you actually know. Do you understand that you know these three things?
Yeah.
You don't know what's alternate segment, I'll show you later. All of them are visual, by the way. The way you understand this chapter will always be visually. Okay?
Yeah.
Shall we try an exam question then?
Exam question. I actually already have a whole more questions that we could try.
For this thing, for this chapter.
Yeah, yeah.
Show it to me, put it in a Jamboard, anything, right now.
All right.
Your teacher haven't taught this and you already given you homework.
He's taught some of it, not all of it.
So what I mentioned here, what has he taught?
I don't think he's taught any of what he taught just now. But he's taught me about the AOB.
AOB, okay, AOB.
Then AO is equal to OB, which is radius actually. Like he's
because
pretty much
radius.
Yeah, so far actually, he's just done a revision, like getting our skills back to like up.
Yeah, just making sure. Okay, I
We'll
mean,
probably learn this tomorrow.
that's probably the right thing to do in a class. He's not being slow. He has to do that for class. He has to do that. Okay, let's see his experience. Let's see. If he's a discipline master and a good one, he is probably gonna be good.
Yeah, probably.
I hope, because it doesn't mean that you're good if you're a discipline master, but if you're a good one.
Okay.
Right, just take pictures. Tell me when you're done so I know whether my Jamboard is lagging.
Oh no, the tablet is lagging actually.
Yeah.
It's not opening this younger.
Starting next week, I will expect your phone. Yeah, for today it's fine.
Okay, put it in.
Okay, I'm not seeing it yet, so just waiting for it. Page 11. I'm still waiting for it. Okay, I'm gonna make it rotate. Okay, so we don't clash.
Yeah.
Okay, I'm just going to move it to the next page, to page 12. Okay, so starting this year, this is not the best way of putting a picture. In the end, put three separate one is better, right? Put three separate one. So question 1 and then question 2 and question 3. Of course, showing me directly 3 is not, it's not a bad thing, but when we discuss, we will separate them. So I do expect you to either copy and paste 3. So at least we have 3 things to discuss, and then we just hide one of them, hide or hide 2 of them, right? Or you can just take 3 pictures, 3 separate pictures or something. Okay.
Yeah.
Okay. So yeah, I understand what he's trying to do though, but he started off very weird. No, never mind. It's not weird. It's not weird. It's not weird. No. I'm going to ignore question 1 and 2 for a while, and then we'll jump back to question 1 and 2. Let's check question 3 for now. Okay, so I haven't covered question 3. For example, I haven't drawn any tangent. So visually, Ainesh, is AB tangent to you?
AD.
AB.
AB is tangent.
Is AC tangent to you?
Yeah.
Now,
we also thought that ACO is 90 degrees.
Correct. Because obvious, okay, or rather obvious or not, look at this for a while. So a tangent actually goes further than that, something, right? I'm not sure whether it's obvious to you or not, but if this is just touching at one point, not 2 points, then this is 90 and 90. It's not just 190, it's 290. They're splitting it nicely. I'm not sure whether this is convincing to you or not, but it is very important to know and use this. Will this be okay?
Yeah.
So you are taught something that is very useful. So I have a 90 so far so good. Yeah? So done, right? Circles at B and C. And then O is a center. They don't have to say this, but it's nice for them to say. There is no other center than O. So, but just to convince you or just to remind you. Right? And angle AOD is 1, 2, 2. So here you go. 1, 2, 2. He needs to... Does he need to say to you what COD is? Does he need to say to you or not?
That is a straight line.
Okay, you think about it carefully. The question maker need to say to you that COD is a straight line or not?
Yeah, it does.
So if he does not say, then it is not our fault if we are not certain.
Oh, no, he actually said this earlier. Like the previous questions in the worksheet where they never specified if it's a straight line or
not. So he is not a bad teacher, right, so far. So CD is a straight line, and the question is supposed to say that. He's not supposed to ask us to guess, or I think it's a straight line. It looks like a straight line, so I'm going to assume it's a straight line. That's not our job. That's the questions maker job. Okay, yeah. Okay, good. So, right. So let's say COD is a straight line. So good for us, good for the question. He wants BAC. So it is definitely very easy to find BAC, definitely. You don't need anything that I told you just now. You don't need anything that I told you just now. You just need very simple stuff. Can you find?
It's just extending from D to the AB line, right?
D to the AB, I don't get what you're saying. But you can use your mouse, okay? You can use your mouse to tell me what you think.
Like this. My line is really bad, but I think you're interested.
BAC. Now, are you sure that's BAC? I don't get it. Why is that
this and then like that?
Why is that BAC? You can close the triangle. Okay, you can form another triangle. That's what you're saying.
Then 180 minus 122 divided by 2. But I'm assuming they're equal.
Should you assume that they're equal? Should you assume that they are?
In order to assume the two triangles are equal, I need 3 similarities here for congruency. So I have OB, same side. And then I got the same angle, 90
What do you mean by the same angle? 190, okay. Good, good. Then one more thing. Are they congruent, right? Basically, I don't think you can find it. I don't think you can find the last one. At least I don't think so. Yeah, I'm not seeing it though. Can you see anything else?
No.
Improve congruency. No. Don't assume that your method is a dead end. Never. This question, if your teacher's gonna go until the deep end, the questions are a little bit creative one. So you cannot say I try one thing, then I cannot follow through, then I must be stupid. That's one. You cannot say that. Or it is a dead end. You also cannot say that. You must keep it open. Just keep it open if you want to try something else. Just keep it open in your mind. I mean, don't blame yourself and don't blame the method. Understand me?
Yep.
So we are not closing that option. We just leave it like that. Okay, it may be useful in another question. We must think like that. Yeah? Now, is there another way to do this? I like the mention of your congruency. Did your new teacher mention congruency?
Yeah.
Then I challenge you to find another pair of triangle which is definitely congruent and can be proven. Can be. Do you see that? This one definitely can, right? And it's not complicated.
Oh, ACO and ABO.
Prove it.
AO same sides,
Yep.
90 degrees, and then the CO and BO are radiuses.
Radius, good. So they are congruent. No? So maybe they will help you more. I don't know. Maybe.
Okay, let me write this down.
You write this down, and therefore your handphone again for tomorrow, must be on. But you just write down on your page, right?
Yeah.
Okay. Then do something. I'll give you 2 minutes. If you're stuck, send me something. If you're not stuck, even better.
Okay.
Are you sending me something? It's already 2 minutes.
Oh, I'm still finished. I can take a picture.
Okay. If you're stuck, please take a picture. We'll continue from there. Oh, you're sending me using the WhatsApp, is it?
No,
Oh, no, it's not. Okay. So I'm just waiting for a second. Are you sending me something?
Yeah. It's in the demo.
Page what? Sorry.
Well, I think it's on page 11 again.
Oh, okay, that's why. Okay, I'm gonna move it. Sorry, don't crash it.
Okay.
I think in page 12. Oh, okay. So you go to find 58, and that's 58 because they're congruent done. Right? What you really need is BAC. So from what I can tell, your BAC should be correct. 120 minus 1. Why is it 1 to 2? Oh, yeah, it's basically 180 minus 58 times 2, and that will be correct.
Yeah, sorry for my messy handwriting. It's just I haven't written in a very long time.
No problem, no problem. There are shorter way to do this, but this is fast enough, and it shows that you're thinking visually. So far, so me, so good. Now, one thing before we continue, please notice this shape. Okay, from now on, we'll call this shape a kite. Okay, a kite has one point outside the circle, a point that I never show in just now our basic discussion. Okay. For your information, that is so look at page 11. Look at page 11. This is we already talked about radius perpendicular to tangent. That means your teacher talked about it. And we talk about tangent from an external point because the point is outside the circle. We talk about those two. Do you understand? Do you understand that your teacher covered it and it shows in the question just now?
I understand the second one. What do you mean by radius perpendicular to tangent?
The tangent and the radius is always 90 degrees. That's what you said to me. That means you understand. You said that your teacher say that it's 90 degrees. Well, the radius and the tangent is 90 degrees. So radius perpendicular to tangent.
Oh, okay. I just didn't understand the big words. Yeah.
Correct. The big words you don't need to. You understand visually, good for you. I'm just saying that you did cover it. Okay.
All right.
So back to the visualization on page 12, please. Page 12, we will call this a kite. Okay. You will see a kite over and over again. That is why I now decided to name it a kite. A kite is always congruent. One more time. A kite is always congruent. That means the two triangles forming the kite is always congruent. It's a shortcut for us to see. You cannot say that they are congruent because it's a kite. That's not acceptable reason in exam. You still must prove it. But for our thinking purpose, that's a kite. Isn't it congruent? It's a shortcut for us to remember. Understand?
Yeah.
So this shape is a kite. Now, let's look at question number 1 and number 2 for now. Right, let's go to page 13. You're supposed to do question 1 with question 2, isn't it?
Yeah, I'm supposed to do all 3 questions.
Oh, I want you to do question 1 by yourself. Let me give you a hint, okay?
All right.
The hint is, this question, this topic is so visual. If there is no drawing, that's what you need. That means you need to draw yourself. Understand it?
Wait, can you remind me what a chord is again?
One more time. Very easy. Look at the picture, which is in page 13, that means from your tutorial, right? A chord is just something like this. A chord is not a tangent. A chord cuts through the circle. That's a chord, no?
Oh, okay.
Right. So in the page 13, is there any chord that you can see? Just asking.
On the picture.
Yeah, on question 3. Okay, let's just use question 3. AO is a chord. No, AO is not a chord. So the chord have to go like this. You have to go from the perimeter to another perimeter. So if you extend AO and then you say this point and this point, then technically that's a chord. Technically that's a chord. Technically AO you shouldn't call a chord. You should extend it and then cut through both. Right? Understand?
Okay.
So is there a chord in question 3?
No.
There is. There's at least 3 chords. At least.
Huh?
Yeah. But they don't necessarily draw it. They don't necessarily draw it. That's the whole problem. But it's there. That's why I start my explanation by imagine that it's not there and then imagine that it's there.
CD is a chord.
Correct. Which happens to be a diameter also, because it goes through the center. It doesn't stop the fact that it is a chord. A diameter is a chord. Do you understand?
Mm-hmm.
There's 2 more which they don't draw, but it's there. Remember, a chord goes through the circle in 2 points of perimeter, right? So a CD, it goes through C and D, right? That's what a chord is. So B and D are 2 points in the perimeter. They're chord BD. Correct.
But the line isn't there.
Yeah, but the B and the D is there, and they will never draw the line.
Oh,
But
so
it is
B and
there.
C. So B and C.
And then B and C, yeah. Because why? Yeah, because just look at it. Imagine it. That's a chord. That's it. But A and C is not like A and B is not. Just say.
I see.
Okay.
Yeah.
You will start imagining a lot when things get more serious. I mean, question 1, 2, 3 are definitely just more. Right? Now, back to question 1, I'm asking you, you must draw. So if you cannot draw, I suppose that will be the problem, right? Do you need more hints? Tomorrow, do you have math or not?
Pardon? Yes, I have math every day.
Good. So that's the hint I give you for question 1. Are you going to try?
Yeah, I'm trying.
Right. So I want to see your drawing now. Of course, if you draw and you can do, then even better. But I want to see your drawing if you're stuck. Do you have some drawing that you can show me?
Yeah, I don't understand.
Right. Do you have any drawing? Any?
Well, I'm trying to formulate a drawing.
Right. Then let's go to the Jamboard and then we're going to draw a circle. Okay, yeah, good. We start with a circle, right? Okay. And then he said that the radius 8.5, right? And then it's 5 from this. Okay, that's the radius, sure. Right. So nice. The center is the center. Now, the chord. So draw a random chord, please. Just draw a random chord for it. Okay. Is that your chord?
Yeah.
Chord? You're drawing it correctly, you know. I think you're drawing it correctly.
Then I don't.
So your drawing is correct, right? Your drawing is correct. Now, let me give you the hint. You're going to deal with triangle a lot in this circle. We just haven't done that. But for example, you're already dealing in the form of congruency. You'll be dealing with similarity, and you're also dealing with sometimes sine rule, cosine rule, sometimes. So all the triangle knowledge from before. Okay. Now, what I don't see in your drawing is a triangle that we can use. So invent, draw, whatever, but form a triangle that we can use, because your drawing is already correct. Just don't have triangle. Now, why are you erasing it though?
Because it doesn't look nice.
Okay, then do it on paper, because you will not do it nice on mouse. Cannot. Just don't do it on mouse. Don't. Just do it on paper. Okay, it's probably nicer that way. Quickly.
Okay. Where do I draw triangles?
Right. So I cannot see your drawing, but I hope it's the same. Now, draw a triangle, two triangle, I don't know, however triangle, which you think will help you with this question. I know it's not easy, but I think the triangle should first contain the chord line. Make sense? Secondly, it should contain the 5. I guess that makes sense. I mean, 5 is an information we want to use. Thirdly, I think you want it to contain 8.5.
So what if I do this? You can see the drawing on the Jamboard, right?
I will now try to follow.
Paste that too.
Okay, all right. So a triangle like so okay. So let's use don't just draw a line, draw the full triangle so that I'm clear which triangle you're using. Okay, good. Now, here, let me tell you something, Ainesh. For a triangle to be useful, it must be no 3. I covered this with you before, right? Is this triangle no 3?
Sure.
What do you mean by sure? Tell me which one then. Okay, there's a 90. That's 1. Right, that's 1. That's great. I like it. I think it's correct. Then where's the other 2?
And when you got the length, 8.5 plus 5. But
that's one side, right? That's not 2, right? That's one side. So 13.5. 13.5 and 90 degrees. So we know 2. Do we know 3?
No.
I agree with you that I think this triangle only know 2. So that's the start. But we need another triangle. Right. So just to clarify, this is the center, right? This is the center. So it's O, not C. Right? I think you need to use this 90 and you need to use this 5. Form a triangle with this 90 degree and 5. But also you can use the 8.5 information. Form another triangle, please. If you can use the 8.5 in the new triangle, I think it's going to be no 3. That's why I'm guiding you towards that.
Or make a similar triangle.
Can try something. I mean, we must be prepared to use similarity. True. Let's see whether it works here.
I don't know. I don't understand how this is gonna work, but I'm not sure.
Right. So you must be a bit open to new ideas. Right. So that is a triangle. But for that triangle, do you? Oh, can you? No. Can you do? No. Can you? No, you cannot. They are similar though. The green triangle and the blue triangle, I agree, is similar, but you cannot use it. You cannot use it to find this. Because let's agree that this is what you want, right? You want that, but even with the 2 similar triangle, which I like a lot, you cannot use it to find the question mark. You cannot. Then my advice remains, you need to form probably another triangle. Probably. Let me give you further here. You say that this is 8. Yeah. This is 8.5, right? This is also 8.5, right? And this is 90 degrees, right? Right?
Yeah.
So this triangle, you know 3. The problem with this triangle is, does it help you find this one? That's the problem. Don't erase it though. Don't erase it. We must keep our head open. I don't think it helps, but if you think it helps, prove it out.
Nah, I don't understand how to do.
It's not understanding it, it's seeing it. Now, so let me give you a hint. Yeah? This is 8.5, right? Correct. This is also 8.5, right? So you see all that. I think you need to expand your mind a little bit. There are other 8.5s, 8.5 is radius, right? Give me an example of another 8.5. This is 8.5. I know you have already drawn that. This is another 8.5. This is another 8.5. I don't want this for 8.5. Give me another 8.5. And you don't see it. You don't see the triangle. Okay.
Okay, so I do this.
Yeah, if you do that, do you have a no 3 triangle, which is useful to get what you want?
So 90 degrees.
The 90 degree, the 5, and the 8.5. No 3 one. Can you find this guy then? But really, you're a bit rusty, is it? This is no 3 triangle, right?
Okay.
Oh, wait, but is this a no 3 triangle? Is it?
Oh.
Is it no 3 or not?
No.
Then why did you draw this line? You say this line is 8.5. Are you just confused, or are you sure that it's 8.5?
Okay, is this 8.5?
It's radius, right? 8.5, right? 8.5 radius. This is 5, and it's 90 degrees. I would call that no tree. I mean, it's obviously no tree.
Yeah, it is. Yeah.
So will it help you find what you want?
Yeah.
Can you do it?
Yes.
Please do so, because we'll stop on time. Eh? I'll leave question 2 to you, right?
This question 2 the easiest one.
I don't think so, but if you can draw, it will be very easy. If you can draw. I mean, the problem is they don't know.
Okay, sure.
I will see you tomorrow. Right?
I'll see you tomorrow.